Welcome, everybody. Thank you so much for joining me today to go over the ClearEdge Rithm software. This is our third webinar that we've done. First one on Verity. Then the other was on magnet collage. And then today we're going to do Rithm. My name is Andy Huntley. I'm the National Scanning Technology Sales Manager. I've have over 10 years of experience doing some kind of positioning technology work. The last company I worked for, I actually was in charge of the scanning technology for a large concrete construction company. So I got to use Rithm almost every day of my life. Beyond that, I've pretty knowledgeable with all the other positioning equipment, be it total stations, GPS, machine control, scanning, and drones. Today, like I said, what we're going to do is we're going to talk about Rithm. It is the third software in the ClearEdge platform that works with your concrete contractors and your GCs. Today, I kind of want to just show you some small little features that Rithm has that maximizes the most out of your scan data. The very first one, though, we need to set up our projects, and the way we set up our projects, it can be sometimes a little difficult, but I want to show you guys the easy way of doing that. The next thing we're going to do is talk about heat maps and show what are easier ways to understand them. There are different color options you can do. So if your company has a certain style you guys like for cut and fill maps, things like that, we can set it up that way. The third option we're going to show is contour mapping. And what is so great with contour mapping is we can actually use that data outside of the computer. We can take that data back out into the field and start laying out points, our highs and our lows. Fourth, we're going to talk about the FFFL reports, how to do them, where when you create a report, you're doing a legal document, not so much of a, hey, I'm going to just snap a bunch of lines all over the place. And I'll talk about that a little bit. So with that all being said, let's go ahead and jump out and let's get into Navisworks. Rithm resides as an app inside of Navisworks, just like Verity does. The first example I'm going to show today, I'm going to use this little point cloud here. Give you background on the point cloud. What it is it's a concrete pour that we went in and scanned it with the GTL 1000 right at the beginning of, or right after it was poured. So this is before any machines are on it trying to rake the concrete down and flatten it and smooth it out. So the first thing we need to do once we bring our data in like this, we need to analyze it. And this is where I told you about setting up our files. What Navisworks wants us to do is to save this project. Well, I'm going to save it right onto my desktop because I want it somewhere quick and easy for me to access. And I have a thing called Rithm data. And we'll title this and hit save. Now, we saved our Navisworks file, our UF. Now we also need to create a Rithm file. And the reason we're doing this is all the data that Rithm collects off of this, because it is a software app built into Navisworks, we want to store it somewhere. So it's going to ask, what do we want to call it? And where do we want to put our data at? Well, like I said, I'm putting everything on my desktop just so I can easily find it and move it where I need it to go. Hit OK. And if you don't select your slab, it's just going to bring everything in. And this is what this warning map is showing. We'll give it a couple of seconds. You'll see the Rithm icon pop up. Now what you see is I have the exact same point cloud as I do in my Navisworks. From here, you see everything's the same, but the windows are a lot simpler. I don't have all of this extra Navisworks stuff. So what I can do is minimize that screen and let's maximize this, because we only want to work with Rithm right now. Once I'm in Rithm, I have these two buttons here. One is Builder. And what Builder is it contains more to your surfaces. So your floors, your walls, and then it also has some analysis tools where we can do a grid of points. Or if we want to check out beam deflection, we can check camber and see does our beams have a positive camber or a negative before we even put concrete on the decks. And then monitoring slab changes. The other toolbar we have in Rithm is our inspector toolbar. Inspector is where we do our reports. We have our floor flatness ASTM 1155. That is the dipstick report, the FFFL, and hence why there's a dipstick looking device on it. The other report is going to be our ADA report. And we'll go into that at a later date, because there's a lot of rules and regulations that go to ADA, and we don't have enough time to deal with that today. All right, so the first thing I want to talk about, since we've got our folder structure set up, all our data is being stored in the same folder, let's go into our heat maps. So I'm going to click on Surface. When I click on Surface, I have a couple of different options. I have the Surface Wizard, which is kind of like a software install wizard where it automatically configures things for you. Or we have the Wet Concrete, which will allow us to go in real quick and check the wet concrete and set up the filters. It's predefined filters that will go in and do a heat map of it. And then we have what's called a debris filter. What debris filter does is it removes points that we do not want included in our contour maps or our heat maps. So if I have a bunch of stub ups or a trash bin in the middle of my scan, it will remove that trash bin and items like that, or power cords. And I'll show that here with the Surface Wizard in a second. The other two or three options, we have our contour mapping, our heat mapping, and then our wall heat map. They all basically are saying exactly what they are. The two are containing for the floor. The wall is if I have a shear wall that I wanted to see, is there any bellies, or is this wall not perfectly plumb? Things like that. So with all of that being said, let's get started using the Surface Wizard. The way we use the Surface Wizard is we had to draw a box around what we want to basically create a heat map of. And it doesn't have to be a perfect box like you see here. I'm just tracing around something. Once I have the outline of the box I want, I've got to close it up. So I hit the enter button. At this point, the Surface Wizard pops up and it's going to ask, what kind of floor are we working with? Along with that, it's got the debris filter right here. So we want to sample more points. The ground's fairly flat and smooth. There was nobody on the slab, but we're going to say get rid of power cords, ropes, and tools that you would typically find across the deck. And then since there was no trash out there, I don't have to worry about setting up a debris filter around. Once I get all that done, we hit next. It will ask us at this point, what would we like to do with the data? Do we want to create a contour map, or do we want to create a heat map? For the first example, we're going to do a heat map. Once I click on heat map, then it's going to turn around and say, okay, what style of heat map do you want? You want a high or low, or cut and fill? For this one, we're going to do the high and low. And then if I had a base elevation, I knew what my elevated slab or my slab on grade was supposed to be, I can actually set that as my 0 point. But since I do not know any of that the elevation for this concrete slab, then I'm going to just say, okay, let it find its median point, and it'll base everything relative to itself. So I'm going to hit apply. And then it's going to sit here and pull up the legend. It will also ask me, am I happy with it, my results? Well, yes, I am. So like you see here, we have this whole entire contour map, or not contour, heat map. And a lot of times, my personal preference, I don't really like the green because it starts to blend in too much over in this area. So since I already have that in there, let's go back to our heat map and we can change our color scheme. I'm going to change the green to a white, hit OK, and apply. Hit confirm. Now you see this looks more like what we would see as a cut and fill map. Now, the one thing I will say is this slab, this is exactly poured right. This is a parking garage that is being built in Dallas, Texas. And they wanted to see how the contours looked as it was going up the ramp. Well, as you see, everything is very smooth. We do not have any pockets here. Like if there was a really high spot, it would be darker red. Where this is the lowest spot, it is darker blue. So heat maps allow us to quickly on a site see where is the highs, where are the lows, so we can easily go in and tell the finishers, hey, I need you to focus on bringing this area up or bringing this area down to yield us the most flatter floor possible. The reason you want the flatter floor is if your spec is requiring a higher FF, which we'll get into in a little bit, you need it as flat as possible. Now, since we have this heat map and it's a great heat map, let's see what the contours look like for this. Well, instead of having to draw around the box, here's a tip I always tell people. Go back into your filter, and there's a button right here that's called Add Surface. Once I hit that, it's basically, we don't have to reprocess all the points again. We're just going to say, okay, off of these points, because I like them, we're going to create the contour map. And then the contour window is going to pop up. It's going to ask how many times you want labels, or how densified label spacings do you want? How smooth do you want your contours lines? Do you want them really jagged where it's going from point to point, or do you want it to flow? And I recommend somewhere in the middle, just because a lot of times these are exhibits where we're displaying something. The next thing is how many contours do you want? I typically say I want a lot of them if I know that the slab is got a lot of grade changes. If the slab doesn't have a lot of grade changes, then I'll be like, okay, not so much. The next option is what type do we want? Do we want a high to low, cut or fill, or just plain contours? I usually do the mini colors and hit OK. So it's going to take that filter settings that we had. It's going to go through all the points, and it's going to create the contour maps based off the points. Are you satisfied with the results? Since I've seen this data, yes, I am. And I'll show you this data here in 2 seconds. I'm going to pull up our legends property, or not legends, but the layers property. And we're going to turn off our heat map. With the heat map off, now you can see our contour lines are smooth. And this is the benefit of having a GTL 1000, because we can go in, scan with the GTL while the instrument is still on the deck, and then run the data right through Rithm, get our contour maps. And at this point, here's the best tip and trick I can tell anybody that has a scanner with a robotic total station. If your point cloud is registered to control, or you are running like the GTL 1000, we can take these contour maps, export it as a DXF. And the reason I want to do that, we're going to go right back into the Rithm folder. We're going to call this CAD and contours. The reason we do this is because I now have a file that we can bring into our field collection software. And there's our DXF. Let's go ahead and open up magnet field layout. And from here, and then I want to bring in that DXF. So it imported all of those line works right in, like so. So had I had my data collector or my instrument set up, since these are on the same control points or same coordinate system as what my instrument is set up on, I would be able to lay out each one of these lines with a robotic total station, or if I had a manual total station, I could do the exact same thing. And then if I had a laser pointer, instead of having a guy walk across the slab and sink into the concrete, I can just point a red point right on top of where that line is and say, hey, you're high here or you're low, like you're high over here and you're low over here, very quickly. I would say the most time I spend is about 15 minutes from start of a scan to processing through Rithm to bringing it into this point and laying out points. Now that we're done with that, we'll close that screen. And from there, so you guys see the power of what just a heat map can deliver, and then how we can benefit with contour maps right out of Rithm. The next thing I want to show you guys, I'm going to come back to the PowerPoint, is FFFL. Many of you guys are not familiar with this, but there are some rules that we had to follow with it. These rules are set in stone rules that ASTM has set out in their specs book. They date back to like 1980s to 1970s. The number one rule is must stay out of what's called the 2-foot boundary. That's 2 feet from the slab edge, unless the area of excluded is more than 25% of the slab. Then we have to go all the way up to the slab edge. The next one is you must stay 2 feet away from any penetration. And that's going to be your blockouts, your sleeves, stub ups, drains, embed plates, anchor bolts, etc. And the reason behind it, as a tip, is because a lot of times the finishing trowel machine can't get close enough up to those points. Or if it's a drain, all the concrete slab is just sloping down to it. So you don't want to take any readings near those slab drains, because the way FFFL works, it's all based off of elevation change. So that's why the rules clearly state that stay 2 feet away from any slab penetration. The next thing, to make this any kind of legal report, the biggest thing you've got to do is you've got to have the same amount of lengths of lines going north and south as you do east and west. So over here on the right, I've got some examples where the right way, you notice I have two sets of lines on the top one going up and down. One's a long one, one's a short one. And then they just basically copied it and rotated it 90 degrees. And now I have a long one and a short one as well. That is a legal report. Over further right, you see all these different things. Well, the reason those are not legal reports is I'm not getting the same amount of data going east and west as I am north and south. So if I was to submit a report that looks like what's on the left or the far right, in court, that would be ruled out by anybody that is certified to run a dipstick or do FFFL. Now, on the bottom set, the three boxes, you notice those lines go a different direction. Those are called zigzag lines. And with those zigzag lines, you can go 45 degrees. But when you do the 45, the lines that cross those 45s have to be 90 degrees. So you're still doing parallel and perpendicular lines. The last big thing is the minimum length of the line has to be 11 feet. And the reason that is because of your FL. FL takes a minimum of 2 readings to get. And once you have that, then you can go in and do a legal report. So I want to show you guys what that looks like. Here is a typical building slab that you would see at any job site, be it a house slab or like an office slab, anything like that. So like I said earlier, let's go ahead and open this up. All right, so I have my Rithm report open. And here's my house pad. A fun little trick is if you need to rotate your building so it looks more like this and not turn sideways, if you hit Shift and your scroll button on your mouse, you can orbit around your pad. So once I get the pad somewhat where I like it, we're going to open up our inspector toolbar. With the inspector tool, like I said, I have the floor flatness and the ADA. This is a flat slab, so I want to do the floor flatness. Now, what it's asking is for me to create my lines. There are some hidden tricks within this that a lot of people don't realize. One is being, if I had a perfectly rectangled slab, I know what my the short length is, and we'll just say I'm going to start here since I'm supposed to be 2 feet outside. And then if I type in 25, it will automatically create that run length. Very simple. The other thing I can do is, if you notice here, it says hold Shift and you create lines. And then if you hit Shift, you can create a parallel line. And if you hit Control, whoops. If you hit Control, then it will create a perpendicular line. And since that one is going outside my 2-foot boundary, all I do is hit the backward button, and it allows me to go and erase that line. The next one I'm going to do is right here. So you notice just by using my Control and my Shift, I'm quickly going in and creating my FFFLs. The next thing I can do is say I want to do a line here. I can just click a start point and an end point. You notice how the error came back? It's shorter than 11 feet. So the system won't, it will allow you to create the line, but if you ever get that warning as a tip, delete that line out and just rerun another line that you know you can get that 11 feet out of. That being said, I'll put that there. And then if I want to add a couple of more lines to help my results out, I can definitely do that. Another rule I did not bring up, but if your reports ever go to court, you must maintain a 4-foot buffer around any one of your runs as well. So you notice how I've got wells spacing across this. This would be almost a legal report. Once I have all of that set up, I just hit the enter key. It's going to ask, did I do all my runs that I need? Yes. And so from here, you can start seeing what this slab actually looks like. Here are each one of my individual runs. And you see a FF and then an FL for each one. Down here, though, is the most important ones. Your overall FF and your overall FL. Majority of your construction projects are based off of these numbers. These are your specs. So if I say, hey, I like this report, I'm going to take a screenshot real quick because I like where this image looks compared to this. Now I just got to come in here, choose where I want to put my data at. We'll come up one. Give our report the project name. So I'm going to say this is project this number. And then location. Where did the concrete poured go? So the reason I ask that is if I'm doing a high rise, well, we know the project's name is going to be whatever the high rise's name is. The location, typically, like if I was pouring floor 32, I would do level 32, pour 2. Once I have that, then you can go in and hit create report. Give it a minute. And it's going to create a series of documents. Just like this, I have the ASTM E1155 as a PDF. It has the date the project name, project location, the scan date or the pour date and the scan date. Those two dates are also very important because when it comes to FFFL, we have a certain time window that we can pull a legalized document out of. The next big thing is it's going to tell us our overall flatness and our overall levelness. Once we have all of that, then from there, we can sit there and it breaks the whole entire slab down. So these are our specs. Here's our FL or our FF. Here's our FL. If you notice, based off the spec, I was supposed to hit a 35 and I hit a 34.80. I failed. These specs are easily changed. So if I close that, I come back to the report and you notice here's my specs. Well, typically house pads are about a 50 and 35. But since we want this to pass, we'll say 25, 15, and I believe this one should be like a 10. And create the report. Give it a second. Here's our PDF document. Pass, 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 pass. 25, 15, 15, 10. Then it breaks down every one of our runs and also gives us a profile view of that cross section of the slab. So you can start seeing where the humps are and at what footage length was that high spot or that low spot. This also exports as an HTML document and a Word document. So if you guys have your own like letterhead that you like, another tip, you can easily put in your company logo. And then you can export this as a PDF and send it out to whoever you need. Or if you want to get rid of a bunch of extra stuff, like you don't really care about the FL mins, you can delete those out. So with these 3 simple little tips and tricks and functionalities, you can easily get more bang for your buck out of the Rithm software. At this point, does anybody have any questions?
Andy, got a couple questions for you.
Okay.
So how dense does your point cloud need to be? How many setups do you think you need to do to get a good FFFL number?
Okay, great question. Density of the point cloud, you want it somewhat as dense as possible. It doesn't have to be super dense. And the reason being for the FFFL is if I come to the settings, I can choose kind of how many points of density do I want to collect out of like a 2-foot or 2-inch circle. So at that like foot 1, I can tell it, hey, I want you to see 10 points to build an average off of that. Or in this case, I have it set as 1. So you don't have to have a super dense data set, but I do definitely recommend having some overlapping scans with it. So with that being said, that answers your second part of that question. How many scans you need? I always recommend at least 2 to 3 overlapping scans that can tie into those. So that if you do have an anomaly in the point cloud and it gives you one bogus elevation in that area, you have 2 other scans that can kind of fix that up for you. Does that answer your question, Jim?
Yes, and kind of to piggyback on that, so you've got an area where there might be a column. So it's going to be, if you do one setup, you have a shadow behind that column. And second
Correct.
setup, hopefully get most of that shadow taken care of. How much of that shadow really needs to be covered? Like right in your scan right there, there's 2 shadows kind of top middle.
Right.
And I'm assuming since we're not running our lines right over those shadows, we're okay. Is that kind of the rule of thumb? Just don't run your lines over the shadows, or have enough scans that you cover all the shadows?
It's either or. A lot of times on a construction site in concrete, we're kind of at the mercy of where you want to scan a high-rise deck. You want to scan it as soon as that concrete is able to walk on, because at that point, they're not bringing a bunch of stuff in. But if you miss that window, you're going to have a lot of items on your deck that you're going to have to clean out. So if you can catch a concrete deck like this, you'll have room to put lines anywhere in here that you see. But if we miss that window, you're going to need to cover up all your shadows, because like one of these runs here, we'll just grab the lowest one. I don't like that run. I can actually delete this run, and this is in the gray area of the ASTM. If anybody asks, you're appending the run. You're not technically deleting it, but I can go back and add that run in. And so if I have a bunch of shadows, well, it starts limiting where I can put that run at. So if I want to put it here, since that's not edit, come on. Okay, this is a fun little thing I see all the time in Rithm. So what Rithm's doing is basically creating a second layer of FFFL reports. Okay, so mine kind of crashed on me. But no, if you have a lot of shadows, you limit the amount of locations you can actually pull data from. Does that answer that question?
Yeah, because if you run a line over a shadow, is it going to yell at you, or is it just going to jump over it?
So according to the rules, it has to pull a elevation point at every 1 foot increment.
Okay, so if the shadow's 6
if
inches
you land in
wide,
that
it's
shadow,
not big of a deal. But if it's a 2 foot shadow, then it's a problem.
Yes, and it will air the line out.
Okay, thanks.
Let's see if I can actually air a line. Yeah, that's what I was figuring. So I'm going to go right through this little block out area. Hey, look, there's all my points. Okay, that'll work. And then hit enter. All right, come in here, hit enter, let it generate its report, or try to. I've got too much going on my computer right now, so it's kind of trying to crash itself. It will, if it cannot pull an elevation from that foot mark, it will actually air the run out. So you know, hey, that's a messed up run, and I need to append it, and I need to move it. Or if you have you go across a high point, like a rope or a power cord or something, and it finds it, it'll potentially, depending on how you have your settings set, it will air the run out. So, any other questions? All right. Since there's no, oh wait, I got one more. What's the maximum distance the scan to gather the FFFL? So the maximum distance of the scan, user preference for me would be, I typically kept scan data anywhere from the start of the scan to about 100 feet out, maybe 150. The reason being is all scanners have a tolerance level, and the further out you go, the more it multiplies itself. So with like our GTL and our GLS, we're about 3 millimeters at 10 meters out. So that's about 3 mil at 30 feet. Well, if I go at 100 feet, well, I'm a little over double that. So the points at 100 feet could be potentially at 6 mil tolerance. And that's any scanner out there on the market. So you don't want your data, you don't want to use data that's really far away from the scanner. So you want to keep data close up. And then that goes back to Jim's question of how many scans you need. You need the overlappage because of that reason. Any other questions? All right. With that, I'm going to go ahead and stop our PowerPoint and stop our screen share. I want to thank everybody for coming out. And if you got any questions or like to know more, please feel free to reach out to myself or any of our TopCon representatives. Thank you so much, and please have a good day.